This is the second question of midterm version C, which if you've done this, this is the single hardest question on both of the midterms that I posted. So yes, it is hard, but well, it is usually taught in the public good section, the basic last chapter of 206, but I put it on the exam because with the information you know, you should be able to do this. So it requires some thinking, so I don't want to say that it's easy, so let's get to do it. The thing is, we need to change it to pen. So the first question is free mark. So we have two players. First player values the good at 1, second player values the good at 2. So the game goes like this. So if one player bid, so both players submit a bid, and then if one player's bid is larger, then that player gets the good and then pays the bid of the other person. So for example, if the first person bid 1 and the second person bid 2, then the second person gets the good, which she values at 2, and pays the bid of the other person, which is 1. The first person gets nothing, so it's 0. So that's why we get 1 here. So this is 1. And similarly, if it's 2 and 1, then the first person gets the good and pays the second person's bid. So the first person values it at 1 and pays 1, so I get 0. And the second person doesn't get good, so I get 0 as well. Similarly, if both of them bids the same, then there's a default. So the second person gets the good and pays whatever this bid is. So the first person didn't get the good, second person gets the good and need to pay 1 because both of them bid at 1. So it's 0 and 1 still. And here, 2 and 2 means the second person by default gets the good and pays 2. She values it 2. So it's 2 minus 2 is 0. So this is very easy. And drawing the circles is even easier because all of them are best responses to each other. So all of them are Nash equilibrium. So that's, well, kind of surprising, but it's possible too. And some people think that we need 3. Yes, we need 3. But for this question, I won't deduct mark if you don't have 3. So normally you should have 3. So you have a larger game. You can include 4 and 5 as well, but it's okay. So some people think you need 0, but it says it's positive integer here, so you don't need 0. Um, then go to the second one. So as we said, everything is Nash. So are all Nash equilibrium. That's all you need to write. Moving on. So this one is the hardest part. Yes, and so let's look at this. N minus I is the highest bid made by all other buyers other than I. So the best response, if you spend some time, you can actually think, when you think about this, it's actually not that hard. So the thing is that this is the largest bid of everyone else. If this is larger than I, what this means, this is the value, this is my valuation. So if I get the good, I get I. But if I get the good, I need to overbid this. So I need to bid something that's larger than this. But I pay the highest among everyone else's, so I pay this. I pay something larger, I get something smaller. So that's not going to work because I will get a negative number. So maybe I should lose. So in this case, I want to lose. Losing means bidding anything that's smaller than this, I will lose because mine will not be the largest. This one will be the largest. So basically anything smaller than n minus I, it's okay. Then let's go through the same logic again with the other one. If this other people's bid, highest bid, is smaller than my valuation, this is what I pay, this is what I get. So I get more than what I pay. So I make a profit, I want to win. So the way to win is to overbid this. Because when I overbid this, I will pay this. Right? So this becomes the second largest. When I overbid it, I don't pay my bid, I pay the other highest among everyone else's bid, which is this. So I will make a profit. So I want to win. The way to win is to overbid this. So this is done. Right? So on the exam, you don't need to write this even. So you can just write 0 and n minus plus 1. So maybe not that extreme. So maybe just this minus 1. then it's okay. So yes, I have the complete best response function in my solution, but you don't need that because that's a best response correspondence. You don't need that complicated for midterm 3. You just need to specify one action after all possible action of the other people. So this thing covers every possibility, and this is one of the best responses. That's enough for this exam. You don't need to specify the whole thing. Alright, so yes, again, I have the whole thing on my solution. You can take a look at it and try to understand it, but this is all you need to do for this midterm. So one best response, one of the best response at least for all situations, that's all you need. And then going to the Nash one, that you need to take a guess. So the easiest guess is normally what you do, right? You bid your own valuation. So 1, 2, 3, 4, 5, n minus 1, and n. So first, if we bid like this person will get the good and pays this, which is kind of a best response. So it's best responding. Given everyone else is doing this, I want to overbid it because I get something larger than I pay, so I will overbid it. So for everyone else, they will not get the good anyways. So, well, as long as I don't overbid n, then it's okay. So they are best responding. So that's one Nash, and that's actually one easy Nash. And again, on the exam, you don't need to explain. So as long as you write something that makes sense, it's okay. And if you write something that doesn't make sense, try to explain it to get part mark. So the other one, the other simple one is everyone bidding 0, and I choose n. So one thing that does not work is if I choose 1. So that looks like it works, but the problem is all of these people will all want to overbid this 1, right? So if I change from 0 to 2, then I overbid this guy, then I pay 1 and I get n minus 1. So that's not working. So the first person, I need to bid large enough. So I need to bid n. I need to bid at least larger than n minus 1 so that no one else wants to overbid me. Then it's done. Then this is a Nash 2. So everyone else won't get good anyway, so they can bid anything they want. And this person is, I mean, all other people don't want to win, so they can bid anything lower than this n. And this person is getting a good, so bidding anything is okay. So this is a Nash equilibrium. So these are just two examples. There are a lot of them. So I provided a subset of them. So in my answer, it's not complete as well, but it's a large subset of the Nash equilibrium. So the last one, is it likely for the players to coordinate? You can answer yes or no. If you say yes, it means you are getting the Nash equilibrium that's 1, 2, 3, and 4, and n minus 1 and n. So this is easy to coordinate because everyone is bidding their own action, so there's no confusion who's bidding what. So I just bid my own valuation. So everyone is basically having some kind of dominant strategy, but it's not dominant here. If we have incomplete information, it will be dominant, but we don't want to talk about it here. And anyways, if you say yes, you give this example, then it's okay. If you say no, then you say it's hard to coordinate on one particular Nash. That's okay too. So either way, as long as your explanation makes sense, then it's okay. But the outcome is actually very easy to coordinate on. So basically, always the person who values it the largest will get the good. That's the same outcome. Is very easy to call it on because all the Nash equilibria has this property. So